Okay, the problem for this video is to prove this statement here. Talking about the equation of a line, we want to prove that an equation of the line containing the 2 points, x1, y1, and x2, y2, may be expressed as the determinant given here. 3 by 3 is equal to 0. So what you have to do then is just leave it as an equation equal to 0 here. Expand this 3 by 3. Now there's many forms of the equation of the line. You have the slope-intercept form. You have the 2-point form of the equation of the line. So this is what we have to do. We want to expand this 3 by 3 and show that we can put it in this particular form. Right here. Y minus y1 is equal to y2 minus y1 over x2 minus x1 times x minus x sub 1. And of course, this right here actually represents the slope. So we're going to expand it. If you want to pause the video here and you want to try to do it, it's basically just an exercise in basic algebra. You're going to expand it, and then whatever you get, you're going to have to make it look like this. If you can make it look like this right here, this form here, then that would prove the statement. If you want to stop the video and see if you can do it, go ahead and do it. Like I said, it's just an exercise in basic algebra. But here we go. I went ahead and did this so you can see it a little bit better. So what I did is I expanded it using the first row. So here's the way it works. You take every first component of that row, in this case it's x, and you multiply it by its cofactor. So you take away the row, take away the column. What's left? This right here. This 2 by 2 determinant. You have it here, y1, y, y2, y. And then you go with the next component of that same, whatever row you choose. I chose the first row, or you can choose the column. Now keep in mind that the sign changes as you go from one component to the other. So if you're in the 1-1 position, it's always positive. But then the next one changes to a negative and then to positive, and it just alternates that way. If you start with the second column and go down y, y1, y2, that's in the first column, or first row, second column. 1 and 2 is odd. That's a 3. That's odd. So it's always -1 to that power. That's why if you start in a even position, a 1-1 or a 2-2, then it's going to be positive. But the next one's going to be, that's where this negative comes from. And then we just take away the row that the component of that row is in, and the column. There you go, like this. What's left? x1, 1, x2, 1. You get this determinant right here. You have it. And then we clear this. And then we go to the last component of that row. It's a 1. So I should have a 1 here, but it doesn't really matter because 1 times anything, it's the same thing, right? So, but if this had been a 2, I'd have to put it in there. So there's the 1 times that. So again, the cofactor of this is found by taking away the row and the column. So eliminate this. What do we have left? x1, y1, x2, y2, and there it is. And then we continue with the expansion. It's just an expansion, regular expansion of a 3 by 3 using a row or a column, whatever you choose. I chose row 1, and then following the steps for expansion. Okay, so I just went ahead and left this out now, because now we're just dealing with the rest of it. Equal to 0. So then I continue. Well, what we're going to do now is a 2 by 2 is evaluated by just cross multiplying and subtracting. So it's going to be y1 times 1 minus y2 times 1. And the next one is x1 times 1 minus x2 times 1. So that's x1 minus x2. And I left the 1 out here, again, because 1 times anything is the 1. And then for the next one, okay, cross multiply x1, y2 minus the other product, x2, y1. So that's how we're getting these, the next one over here that I have. cross multiply, subtract. We get this right here. Minus y1, x1, minus x2, and then x1, y2, minus this product. You can write this as y1, x2, or x2, y1. The order doesn't matter since it's multiplication. Okay, remember, the objective is to get it in this format here. This is what I want to come up with. If I can come up with this, then that proves the statement. So now, in the next step, what I'm going to do, I know what I want. What I want to have on the left side. I want to have y1 minus. I'm sorry. I want to have y minus y sub 1. So I want the y on the left side. So what I'm going to do here, and I want the coefficient to be positive. So I'm going to distribute this minus here that I have here, and put it here. Put it through the parentheses. So minus 1 times x1 will be a minus. Minus 1 times the minus x2 will give me a plus x sub 2. And then I'm going to take this term over to the other side. This I'm going to take over to this side. This one I'm going to take over to this side. I'm just bringing it over, so it's like adding the opposite to both sides. So that becomes a minus x1 y2 over here. This is minus. When I bring it over, it's like adding the opposite here. So I'm adding a plus. Over here becomes plus. So that's going to make it y1 x2 over here. And then I'm going to take this one over to the other side also, to the right side. So I'll be adding a negative x y1 y2. But what I'm going to do, this will be negative here when I take it over. But then I'm going to distribute the negative through this parenthesis. So this will become a y2 minus y1. y2 minus y1. And that's only so it gives the same look as the original setup that I want. Just showing you how I'm getting the next step. Okay. So remember, this was a minus y. I distributed the negative. So this instead of x1 minus x2, this became x2 minus x1. And then I took this over. So become a negative over there, but I've distributed a negative on this parentheses here. So these change signs. So on the other side, I got x, y2 minus y1. And then those other terms, I can just change signs. Okay, so from here, in my next step, I know I want to have y minus y sub 1. So here's what I did. I just added minus y1 x2. So notice this is the same. x2 minus x1. All I did was put a minus y1 there. Now that's legal. That's legal. As long as you do it to both sides. So over here, I did it over here. Minus y1, x2, minus x1. And now what I'm going to do here, notice I have a x2 minus 1 and x2 minus 1. I want to factor that out. Because remember, I want to come up with y minus y1. I'm going to factor this out on this side. We'll go to the next step here. So here we have, so I'm going to have y minus y1. That's what I want on the left side. And then the common factor, put this in parentheses for now. Factor out the x2 minus x1. And this is equal to x and parentheses y2 minus y1. Okay, so now over here I'm just going to multiply through with this. Minus y1 times x2. So this would be a minus y1 x2. Okay, then multiply over here. Minus y1 times a minus x1. So this will be a plus y1 x1 sub 1. Okay, so I'm just going to mark this out for now because that replaces. I multiplied that, so this takes the place of what I have right there. So now look at what we have here. So notice right here I have a y1 x2, and here I have a minus y1 x2. So these are going to cancel out. This and this cancel out. And then I'm going to take this term right here and this term over here that's left, and I'm going to factor out the minus x sub 1. So let me do it this way. Minus x sub 1. So from this one, then I take out the minus x sub 1. That leaves me with y sub 2. And on this one, I take out the minus x sub 1. And that's going to leave me with a minus y1. Y sub 1. Now we look at what we have here. We have x, y2 minus y1, y2 minus y1. Okay, so we have a common factor in those two terms. Now I'm going to factor that out. Again, this is no different than proving an identity in trigonometry or other courses. That's what we're doing here. y2 minus y1. Put that in parentheses, and then I put another parentheses. So I took out the y2 minus y1 from this expression here. That left me with an x. And I took it out from this one. That left me with a minus x sub 1. Okay, so now we got this is equal to this right here. So now I continue. Remember, on the right side, or the left side I should say, I want to wind up with y minus y sub 1. And to do that, all I had to do is divide both sides by x2 minus x1. So if I divide this side by x2 minus x1, this is going to cancel and leave me the y minus y1. And then on the other side then, I have y2 minus y1 divided by the x2 minus x1. And that's multiplied by x minus x sub 1. So y minus y1 equals to y2 minus y1 over x2 minus x1 times x minus x sub 1. Remember, this right here is actually your slope. That's your formula for the slope given in 2 points. So this does define the equation of a line that is in 2-point form. And that's what they wanted us to prove. Again, this is just a little tedious exercise. That's why I set this up like this. Be easier to read. Wanted to do the last part so you can see the actual steps here. But I hope this was clear as to how it was derived. And I appreciate you watching the videos. And we'll see you next time. Again, thanks for watching.